Hello everyone, this is Shyam Babu, Assistant Professor, Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad. Today, I am giving the lecture on Modulation and Demodulation methods of DSB-SC. In this session, we discuss about what are the generation methods, nothing but it is also called as modulation methods, and demodulation methods of DSB-SC, along with the time and frequency domain representation of the DSB-SC. Then, before going to the modulation and demodulation methods of the DSB-SC, we have to fundamental equation of the DSB-SC. Observe here, actually, when generating DSB-SC signal, we need M of t and we need C of t. Then M of t is AM cos omega mt and C of t is AC cos omega ct. These two signals are given to DSB-SC modulator are a product modulator, nothing but M of t as well as C of t. Then the output should be DSB-SC of t. The equation should be observed here. The carrier should be suppressed. Then only we got the upper sideband information, nothing but AC AM by 2 cos omega c into omega mt plus AC AM by 2 cos omega c minus omega m into t. That means here this is upper sideband and this is the lower sideband. It is simple because only with the help of product modulator, when you multiply both message and carrier, then the output should be a DSB-SC. Here the point is in this lecture, how this equation or how this signal can be produced. It is nothing but a modulation. Then what is the demodulation? The modulation needs input is M of t and C of t and the output should be this S of t. This is called as a modulation. Demodulation means the input should be S of t and the output should be M of t. The input should be S of t, nothing but a DSB-SC modulated signal, and the output should be a message signal, nothing but M of t. That is called as a detection or a demodulation methods. Then what are the different methods we had? After that, the time and frequency domain representation. If you take the time domain representation, you can apply the Fourier transforms. Then we go for the frequency domain representation. That's why the time domain representation, that means like this, into t, nothing but a time domain. In terms of frequencies, that is called as a frequency domain. Then one by one we need to look. The first one is, the first method, generation method is balanced modulator. What is that? Balanced modulator. Observe here, it consists of two amplitude modulators arranged in balanced configuration to suppress the carrier completely. That's why once the carrier completely suppressed, then only it is called as a double sideband suppressed carrier system. Then for this one, observe here, I am taking the two AM modulators. One is M1, nothing but AM modulator 1, and second one is AM modulator 2. Observe here, X of t or M of t, it is a message signal. The value should be equal to AM cos omega m into t. Omega m is nothing but a 2 pi fm. And here minus X of t, what is the reason here? Minus X of t or minus M of t. I am applying the 180 degrees phase shift. That's why minus AM cos omega m into t. Then input is message signal, the downward the input is minus m of t, that is given to the modulator 2. For these two modulators, we know very well the inputs of the DSB-SC needs message signal as well as carrier. Already the message signals are given in this side and in this side. Where the carrier should be given here, observe here. The carrier oscillator or a local oscillator, it generates the high frequency signal that is called as a carrier. Then it gives nothing but C of t. You know mathematically the C of t should be EC cos 2 pi of Ct or AC cos 2 pi of Ct, where AC or EC are amplitudes of the carrier signal is given to the modulators. Therefore, here C of t is one input, here also C of t is one more input to the modulator 2. Just compare M1 point of view, this is M of t into C of t, that is equal to S1 of t. Good. And here coming back, here AM modulator 2 point, this is minus M of t is message signal and C of t is also carrier. Then here also it is DSB-SC. The output should be equal to S2 of t. S2 of t. Therefore, S1 of t is nothing but one DSB-SC. S2 of t is nothing but one more DSB-SC. Is both are given to the summer. Automatically observe here, the carrier is suppressed along with for this one. Along this one. That's why the output should be consists only upper side band plus lower side band. Upper side band and lower side band. This is called as a balanced modulator. It is called a two AM modulators. You can provide a balancing between these two and generated signal should be a DSB-SC signal. And the next method is ring modulator. Ring modulator. Observe here, I am taking it's explaining with respect to rectifying sections. Here AF modulating signal is given to transformer 1. And here observe here, how many diodes? We are taking the 4 diodes, D1, D2, D3 and D4. And the output should be DSB-SC. This is one more, because if you applying the AF modulating signal is nothing but a M of t, the mathematical representation, graphical representation is like this. This is the positive half cycle and this is the negative half cycle. When you are giving the positive half cycle to this one, automatically what happens? The diode D1, D2 and D3, D4, 2 diodes are in forward bias and 2 diodes are in reverse bias. Then we got only positive half cycle information. And if you are applying the negative half cycle, again 2 diodes are in forward bias and 2 diodes are reverse bias. Then again the negative half information. That means only upper side band and then lower side band frequencies we are getting. When you are passing the information step by step, nothing but half cycle by half cycle with respect. And also here we have the carrier square wave, and when you passing these signals, the output should be equal to a DSB-SC signal. Observe here, graphically, this is the message signal and this is the carrier signal. When you are passing, we know that with respect to modulation definition, the carrier is passing with respect to the X of t message signal. The high frequency carrier signal is varied according to instantaneous values of the message signal. It is called as a modulation. Same thing here also. The carrier is passing with respect to with X of t, then the output should be observed here. Here D1, D2 on. In this case, D3, D4 is on. In the case of positive half cycle, D1, D2 on. In the case of negative half cycle point of view, D3, D4 is on. Then the output is nothing but upper sideband information, lower sideband information, not a carrier. Not a carrier. Therefore, with respect to balance modulator and ring modulator, these two are generation methods of the double sideband suppressed carrier. Okay, that means the output should be DSB-SC. Right now, we go for a demodulation of the DSB-SC. Demodulation of the DSB-SC. Clearly, observe here, S of t is only upper sideband information and then lower sideband information. if you go for AC MA by 2 cos of omega C plus omega M into T plus AC MA by 2 cos of omega C minus omega M into T. Therefore, this is called as DSB-SC signal. This DSB-SC signal is given to the input. This process is called as a demodulation, nothing but reverse. The output of the modulated signal is input of the demodulated signal, demodulating process. That is called as demodulation process. That means the modulating signal M of T is recovered from the DSB-SC wave by multiplying it with a locally generated carrier and then passing through a low pass filter. Observe here, S of T is nothing but this is the S of T. And observe here one more from the local oscillator generating a carrier frequency. This is a carrier generated by local oscillator AC cos value. And the output of the product modulator is, if you take V of T. That means the S of T, it is S of T. Therefore, adding here, producting here, S of T into C of T. S of T into C of T, that is nothing but a V of T. Then this V of T is passing through a low pass filter. We know low pass filter, it allows only the low frequency components. It stops the high frequencies. Observe here, in the case of S of T, we had only the sidebands, not a carrier, complete carrier. Therefore, it can stop the high frequency components. High frequency components means AC cos 2 pi of CT, AC square cos 2 pi of CT, 4 pi of CT, like that. When you multiplying these two, we got those components. When you passing these two into the low pass filter, then the output should be equal to only M of T, because the low pass filter stops a high frequency components. Then we got only the low frequency. The low frequency signals are nothing but information signal, nothing but a message signal, that is equal to M of T. That's why it is called as a demodulation process. The input is a DSB-SC wave output and output is the message signal. That's why here, what is that? The modulating signal M of T is recovered from the DSB-SC waveform. That's why it is called as a demodulation process. It is possible the detection method. One of the detection method is coherent detection. Then go for the next one, the time domain representation and the frequency domain representation. The time domain representation or the frequency domain representation. The time domain representation, observe here, the message signal is given by M of T or X of T is nothing but AM cos omega MT, where omega M is nothing but 2 pi FM, and carrier signal is C of T is nothing but AC cos 2 pi FCT or omega C is 2 pi FCT. Then DSB-SC modulated signal S of T is nothing but, you know very well, M of T into C of T or X of T into C of T. Then when you take AM AC by 2 cos 2 pi FC plus FM into T cos 2 pi FC minus FM into T. This is the representation. That means this is the output waveform. Here the amplitude. We got only the upper sideband information FC plus FM and the lower sideband information FC minus FM. And you go for the frequency domain representation. The frequency domain representation of the DSB-SC is obtained by taking Fourier transform of the S of T. What is S of T? This is the S of T. Once again write, S of T is AC AM by 2 cos 2 pi FC plus FM into T plus AC AM by 2 cos 2 pi FC minus FM into T. Then this is the S of T. This is the time domain. This time domain can be converted into the frequency domain. Then we go for Fourier transforms. Then this should be equal to S of F. S of F. That should be equal to, observe here, When you are doing the continuous analysis, 1 by 4 AM AC del of F plus FC plus FM plus del of F minus FC minus FM plus del of F plus FC minus FM plus del of F minus FC plus FM. When you are doing the Fourier transform of the given S of t, then you got the answer should be like this. Once you draw the frequency spectrum of this DSB-SC, observe here, this is the carrier information FC, and this is the upper sideband FC plus FM, and this is the lower sideband FC minus FM. This is called as a frequency spectrum of the double sideband suppressed carrier, because the carrier is suppressed here. Actually, this entire figure explains AM. When this dotted should be, we can suppress, then automatically what we got actually, remember only this is the suppressed one FC, here FC plus FM nothing but upper sideband, and FC minus FM, this is the lower sideband. This is the frequency spectrum of the DSB-SC. DSB-SC. Why this carrier frequency is high comparing with these two? Already we take the conditions. Always when you are doing the DSB-SC, we follow the condition should be the carrier frequency much greater than the message signal frequency. Likely, similarly, the amplitude of the carrier signal is greater than the amplitude of the message signal. With respect to those two conditions, we implement and we got the frequency spectrum should be FC plus FM is upper sideband and FC minus FM is lower sideband information. Therefore, in this session, what we learned actually the modulation and the demodulation methods of DSB-SC. We know the modulation methods are simply we discussed it in this class, balanced modulator, and the second one is ring modulator. These two should be modulators. And demodulation point of view, we discuss coherent demodulation of DSB-SC. We discuss these things. In the coming session, we discuss about bandwidth and power calculations of the DSB-SC. Thank you.